This module will demonstrate the configuration of digital DAHDI interfaces, using the same basic approach as the earlier module on configuring analog interfaces. If you're unfamiliar with the principles of traditional digital telephony, we recommend that you review the previous module on digital telephony concepts before proceeding. If you're unfamiliar with DAHDI, you should review the first module in this chapter, which describes how Asterisk and DAHDI coordinate to connect traditional telephony interfaces to an Asterisk system. We'll start by introducing the digital interface cards Digium offers to allow Asterisk to connect to digital lines. Following that, we'll demonstrate the configuration of a card in both DAHDI and Asterisk. We'll also mention a few Asterisk CLI commands you'll find useful when using digital lines in Asterisk. The example here assumes that there is a DAHDI interface card already installed in the system you're using. We also assume that the DAHDI and Lib PRI packages are installed and that makeconfig was run during the DAHDI installation. T1 and E1 interfaces both use a physical RJ45 connection. Because the physical devices are so similar, Digium's digital interface cards are compatible with both T1 and E1 links. There are different framing and coding schemes common for each interface, but those details are usually handled by the device's firmware. A hardware jumper or software driver setting can be used to configure whether a given span is in T1 or E1 mode. Digium offers 1, 2, and 4-port T1-E1 cards in both PCI and PCI Express interfaces. In addition, each card supports an external hardware echo cancellation module. Digium also offers a 4-port BRI card as well as an 8-port hybrid card that can support a dynamic combination of analog and BRI ports. Shown here is a single-span Digium TE122P card with an external hardware echo cancellation module installed. Through the rest of this module, we'll configure this card as a T1 PRI. The steps will be very similar if you're using an E1 instead of a T1, so it is worth watching the example even if you're not likely to use T1. We'll first set up the device drivers and then configure Asterisk to use the device. The first step is to confirm that the card is properly detected by the system. As with the analog card example a few modules ago, we can use the lspci and dmessage Linux commands to do this. Sample lspci output showing the TE122P is pictured here. After we've confirmed that the card is recognized, we can configure its device drivers. This occurs in the system.conf file in the etc DAHDI directory. For each T1 or E1 port, it is necessary to declare the span using the following syntax. None of these settings are optional. We'll go through each to explain what it is and what the likely or possible values are. Span num just identifies the span. In our example, we have only one span, so we'll put 1. The timing source is used for synchronization purposes to indicate whether this side of the span will be receiving or setting the clock for the link. Receiving a clock signal may also be called slave, and setting the clock signal may also be called master. One side or the other of a link, but not both, should try to set timing. If neither side sets it, or if both sides try to set it, the span is likely to lose synchronization and experience frame slips or other problems. These usually result in audio quality problems and could even result in all calls on the span being dropped. A value of 0 means we are setting timing. A value of 1 means that we expect to receive timing on this span. When connecting to a telco, the far-end device will almost always expect to set timing. When connecting to a channel bank or a PBX, it's more likely that you will be the one setting the timing. Our example assumes that this trunk connects to a telco, so we'll set this value to 1. The next setting is the line buildout, or LBO. This setting is related to the electrical impedance on the line. If the physical cable between the span and its next hop is less than 133 feet, a value of 0 here is appropriate. For longer cable lengths, consult the table in the sample system.conf file. Note that it's only the length of the cable directly plugged into the span that is considered. It is not the distance between the span and the telco. We discussed framing and coding options at some length in the previous module. We'll configure this trunk using the standard framing and coding for a T1, ESF, and B8ZS. Putting it all together, we have span equals 1, 1, 0, ESF, B8ZS. We've now declared the span, but there's still more to do. We also have to declare the channels on the span. We're using a standard T1 PRI, so we need to set 24 as the data channel and 1 through 23 as the bearer channels. This is done using the DChan and BChan signaling types. The very last thing we need to do in system.conf is declare a default zone and any load zones so the system knows what indications to use for dial tone and other call tones. We'll use the US zone. We can now save and exit system.conf and proceed to the next step. The DAHDI configuration we've just defined modifies the settings for the hardware device drivers, so the next step is to make sure the drivers themselves are loaded. If make config was run during the DAHDI install, it's very likely the drivers are already loaded. We'll verify whether the right modules are loaded using the lsmod utility to list the modules currently loaded into the Linux kernel. There should be at least one module labeled DAHDI, as well as the WCTE12XP module for the TE122P card. Other card models have different driver modules. Consult your product documentation for details. If the modules aren't already loaded, you can load them manually using the modprobe utility. The module you want to load should be passed as an argument to modprobe. Here we run modprobe WCTE12XP. This will also load the DAHDI.ko module and any other DAHDI modules required to operate the card. Next, we can apply the DAHDI configuration we defined in etc DAHDI system.conf. The DAHDI package includes a configuration tool called DAHDI_CFG, which is used to apply the settings from system.conf to the loaded device drivers. The DAHDI config utility should generally be run with 3 V's so that it gives verbose output of what it's doing. This way we can confirm our changes and see any errors. We've now written and applied the configuration for the device driver, but Asterisk is not yet ready to use the device. Now we must configure the DAHDI channel driver to bridge between Asterisk and the device drivers. A quick note, in order for the span to be used as a PRI, the libPRI package must have been compiled and installed before Asterisk was installed. If that wasn't done, or if you're not sure what that means, please review the downloading and installing Asterisk chapter. We're displaying a simple chan_DAHDI PRI configuration here. We've declared a section heading below the broader channels section to make sure that the options we've set aren't mistakenly included in the configuration for any other channels that we may define in the future. We're telling Asterisk that it should use the caller ID presented on incoming calls, and that the incoming call should be directed to the from_external context. We also set the signaling to something called PRI_CPE. The CPE stands for Customer Premise Equipment. It means that we're telling Asterisk that this is the customer side of the PRI. If we were behaving as the telco side of the PRI, we would have used PRI_net signaling. We also set an option called switch type. Even though ISDN PRI is a formal standard, there are slight variations in how vendors have implemented the standard. Asterisk can be made compatible with switches from most vendors by setting the switch type appropriately. National is one of the more common values for this setting. Other values to try include 5ESS and EuroISDN. Finally, note that the channel range exactly matches what we set as the bearer channels in DAHDI's system.conf. Asterisk doesn't need to know about the D channel because it cannot use it for voice calls. In fact, it can cause problems if you try to tell Asterisk to use the D channel, so you should be very careful to only list the bearer channels here. One final setting we've defined here is the group setting. This is a logical way of mapping multiple channels into a single named bundle, so that when we are dialing over the trunk, we don't have to specify which exact channel to use. This simple configuration is all that's necessary to configure most PRIs. But there are exceptions. There are several other options that can be tweaked in chan.dahdi.conf that we won't discuss here, but that you can review in the sample configuration. If you're using a Digium interface card that is registered and under warranty, you can also contact our technical support department for assistance configuring your hardware. After updating and saving this configuration, remember to restart Asterisk. After configuring DAHDI's system.conf, loading the DAHDI drivers, running DAHDI CFG, configuring Asterisk's chan.dahdi.conf, and restarting Asterisk, you can confirm that the DAHDI channels are available to Asterisk using the CLI command DAHDI show channels. Additionally, you can get specific information about a particular channel by running DAHDI show channel followed by the channel number. There are also several CLI commands related to debugging a PRI. First, to check the status of a span, use the command PRI show span, followed by the span number. This will display if the span is provisioned and active. It will also list the span as up or down, which reflects the status of the D channel. A span may be provisioned correctly and in what's called green or OK alarm state, which means that the physical connection of the span is proper, even though the span itself may be listed as down. This usually means that there is an issue on the provider's switch. There are two levels of PRI debugging available. To enable PRI debugging, enter the command PRI set debug, debug level, the word span, and then the span number. The debug level will be either 1 or 2. The level 1 debug will show the verbose Q931 messages used for call control and alerting. Level 2 debug displays Q921 information, which is usually only needed when debugging timing issues. There is also an option to write debug messages directly to a file. To debug a channelized T1 or E1 that is not provisioned as a PRI, you can use a utility called DAHDI tool. This utility offers information about the status and configuration of any analog or digital DAHDI hardware in the system. If you highlight and select a specific span, it will list the state of the TX or transmit and RX or receive bits. These are listed by channel number. One final DAHDI utility you should know about is DAHDI_GenConf, which you can use to automatically generate hardware configuration. This will add settings directly to system.conf for you, as well as create an additional asterisk config file called DAHDI-channels.conf. After running this utility, you can add the single line #include DAHDI-channels.conf at the bottom of your current chan.dahdi.conf to get asterisk to use the generated configuration. You'll still need to remember to restart asterisk though. One of the major benefits of using a PRI over an analog trunk is that out-of-band signaling allows a PBX to know the exact number a caller dialed. So the incoming dial plan for a PRI doesn't have to have the S or start extension. You can have different inbound numbers to route to different extensions in the dial plan, even though they're arriving on the same trunk. Here we have 3 different DIDs set up. Dialing Digium's main number routes you to the main IVR, but Digium has many different DIDs, including direct calls into support and sales queues. All of these can come in over the same PRI. Making outbound calls over a PRI isn't much more complicated than dialing over a SIP trunk. Asterisk normally wants us to know the name of the exact channel we'll be dialing out on. But if this were strictly enforced on a PRI, we would lose a lot of flexibility. Each individual bearer channel on a PRI is still capable of only one call at a time. So if the dial plan were hard-coded to dial out channel 1, and there was an incoming call already using that channel, the outbound call would fail, even though there might be another 20 or more channels on the PRI not in use. This is why we used the group setting in the chan.dahdi config a few slides ago. We can tell asterisk to dial out the group instead of an individual channel. As long as there is at least one channel free on the PRI, the call should be placed. The syntax for using groups is straightforward. Here we have a pattern matching a local 7-digit number that invokes the dial application. The technology is DAHDI. Instead of a channel number after the technology, we have the lowercase letter G, followed by the number 1. This tells asterisk to dial out DAHDI group 1 for this extension, using the lowest numbered free channel. If the G were uppercase instead, asterisk would dial out the group, but using the highest numbered free channel. It can cause problems if asterisk and the telco each try to seize the same channel at the same time. This is called glare. Giving you the ability to select whether asterisk will dial from the top down or bottom up lets you minimize the likelihood of this happening. Many providers dial from the top down, so it's usually recommended in asterisk to dial from the bottom up, using the lowercase g. Following the group is a slash, and then the extension to pass to the telco. Here we're using the special extend variable to repeat the number that was dialed to reach this extension. This concludes the chapter on analog and digital connectivity. You should now be familiar with the analog and digital technologies used in the public switched telephone network, as well as the DAHDI devices that implement them. You should also have a basic understanding of how to configure the Linux device drivers and the asterisk channel driver for these DAHDI devices. In the next chapter, we'll return to the dial plan to continue growing our knowledge of how to write effective and powerful extensions.